Everybody, I'm Roberto Polli, I'm a solution architect at Partech. I love writing free software and I got a couple of Red Hat certification. I'm very happy to be here today in a way or in another. That's a concrete sign that PyCon Italia is more than a conference, it's community, it's friendship. Before the beginning, I'd like to thank the proud sponsor of this talk, Partech. Partech provides expertise in IT infrastructure and services and business intelligence solutions and applications for the financial market. Today, we will speak about talks and how to use talks to describe a Python project. So, describe projects with code. We will start introducing continuous integration and how it is addressed in the Java world, which includes an overview on project description. Then we show how to isolate Python projects with virtualenv and how to use talks both for testing and project description, from Python version to dependencies and code style. Finally, a fast glance on using talks with Docker, Jenkins, and an example of a Travis IO configuration file that you can compare with the talks example we provided. Continuous integration is the practice of merging all the developer works many times a day. Instead of merging weekly, which causes a lot of trouble because merge were sort of battles between various streams of software. With continuous integration, people merge their work many times a day. Every closed ticket causes a pull request that is tested with the regression and integration test. Then it's released so that other people can get it, update their content, their working copy, and then again restart the development work. Clearly, all these continuous testing activity requires a clean project description because we should know which is the context of the project, which are the components it integrates with, and every single step and use case. Moreover, we need isolated builds because me and another colleague should be able to test and integrate and check in parallel if the software is building correctly and if our patch causes regression or issues to other people. Everything should be reproducible. And to make it affordable, all this testing should be automatic. We should test automatically that all this integration work. Continuous integration is not as an exclusive of the Java world. Too, it has a solid ground there. Java developers are well acquainted with tools like Jenkins, that is a continuous integration server, with Archian, that is an integration testing platform and library, or tools like OpenShift. Python tools for project description are quite valid. Anyway, we can use Travis continuous integration. We can even integrate with the Jenkins that is written in Java. And there are Python specific tools like BuildBot, Talks, and obviously the test libraries like PyTests and Nose. What is a project description? We need to describe carefully our project so that we can test it continuously. We need to describe every step. The Java world has an established standard, the POM, the Project Object Model, implemented by Maven, that is as build software. The POM describes, not only describes, but implements too the whole software development life cycle. It starts with the ability to build libraries and application, take care of dependency downloads, conflicts resolution, unit testing, including the Java version, for example 1.6 or 1.7 compatibility checking. Then it takes care of packaging the software and install it locally to be ready for integration test. There are phases which takes care of documentation, deployment on an application server or a stage release, or even release on remote repositories, that is, distributing software. All these phases are defined in a huge, actually is a huge XML file that specifies which are the remote repositories we should deploy to, which are the remote repositories we download dependencies to. We can even specify a list of mirrors and proxies so we can use layered repositories for download. For example, if we need to download a library from our internal repository, then we specify that all the libraries matching some patterns should be downloaded from our internal repository, and all the other libraries should be downloaded from other. For specific packages, there are even vendor dependent repositories. Well, okay, for you, the people that maybe already know Maven sucks. Yeah, though hated for the extremely complex description of the XML that is quite error prone, the slow build system, Maven surely achieves the goal. Maven enforces a standard workflow. It is the one tool to build, test and deliver, and it has plugins for almost everything. Here you can see all the Maven phases of software building. There is a validate phase, there is a generate sources, process resources, and then compile. Then it process classes, generate test, compile and run unit test. Just test is unit test. If the unit tests are successful, then a package is built. Then here we can intercept and add hooks on all those phases. For example, we can trigger some kind of delivery in the pre-integration test phase so that we can execute integration test on a remote application server, for example, and then after the verify, that is, the integration tests are run smoothly and with a correct teardown, there is the install. The install usually is an install on a remote repository for libraries, or it can be a for example, a stage environment, if we mean to use if we want to use a continuous delivery pipeline.